This video lecture is about particular integral when the right hand side of the non-homogeneous linear differential equation with constant coefficient is sum of two exponential functions. Solve d square minus 2d plus 1 into y equal to e power 2x plus e power x. Here right hand side is the sum of two exponential functions. Solution. To find the complementary function yc, auxiliary equation is m square minus 2m plus 1 equal to 0. That is m minus 1 whole square equal to 0. So roots are m equal to 1 and m equal to 1. That is, the roots are real and equal, so we write m1 equal to m2 equal to 1. Therefore, the complementary function yc equal to c1 plus c2x e power m1x, that is equal to c1 plus c2x e power x. To find particular integral yp equal to 1 by d square minus 2d plus 1 into e power 2x plus e power x, that is equal to 1 by d minus 1 whole square e power 2x plus e power x. So that is equal to 1 by d minus 1 whole square e power 2x plus 1 by d minus 1 whole square e power x. Now in the first term a equal to 2. A is 2. So substituting here we get 1 by 2 minus 1 whole square e power 2x. Here C A is 1. By substituting d equal to 1 we get here 0. So we have here d minus 1 whole square is a factor. So we take x square by 2 as a particular integral in the second term. So yp is equal to 1 by 2 minus 1 whole square e power 2x plus x square by 2 e power x, that is e power 2x, because 2 minus 1 whole square is 1 square, that is 1. So first term is e power 2x and the second term x square e power x by 2. Therefore the general solution is given by y equal to yc plus yp, that is c1 plus c2x e power x plus e power 2x plus x square e power x by 2. Solve the differential equation d cube minus 12d plus 16 into y equal to e power x plus e power minus 2x whole square. Solution. d cube minus 12d plus 16 into y equal to e power x plus e power minus 2x whole square, that is equal to e power x whole square plus 2 e power x into e power minus 2x plus e power minus 2x whole square using a plus b whole square. So that is equal to d cube minus 12d plus 16 into y equal to e power 2x plus 2 e power minus x plus e power minus 4x. E power 2x is obtained by e power x whole square. 2 e power minus x is obtained from 2 e power x into e power minus 2x, and e power minus 4x is obtained by e power minus 2x whole square. Here e power x minus 2x, so x minus 2x is minus x. Now to find the complementary function yc, auxiliary equation is m cube minus 12m plus 16 equals 0. One root is found by inspection. By putting m equal to 2, we get 2 cube minus 12 into 2, that is minus 24. Here 8 minus 24 is minus 16 plus 16 gives 0. So m equal to 2 is a root by inspection. Now to find the other two roots, we use synthetic division to get the quadratic equation. Here m equal to 2 is a root by inspection to write here. Then coefficient of m cube is 1 and coefficient of m square, there is no m square, so put 0. Coefficient of m is minus 12 and constant term is 16. Put 0 in the below the first entry, so 0 here. Adding these two we get 1. 2 times 1 is 2 right here, and add 0 plus 2 is 2 here. Again multiply 2 into 2 right here, that is 4, and add to get minus 8. Now 2 into minus 8 is minus 16, so we get the here the constant term as 0. So this there are 3 terms, means it is a quadratic equation. Coefficient of m square is 1, so here m square. Coefficient of m is 2, so plus 2m. Constant term is minus 8. So from this we get the quadratic equation m square plus 2m minus 8. So this m cube minus 12m plus 16 equal to 0 can be written as m minus 2. M equal to 2 gives m minus 2 as a factor. So m minus 2 into, from this synthetic division we obtained m square plus 2m minus 8. So their product equal to 0. So m minus 2 into m minus 2 into m plus 4 equal to 0. By factorizing this we get m minus 2 into m plus 4. So the solutions are m equal to 2, m equal to 2, m equal to minus 4. That implies two roots, m1 equal to m2 equal to 2. They are real and equal. And the third root is minus 4, that is distinct. So yc is equal to c1 plus c2x e power m1x plus c3 e power m3x, that is equal to c1 plus c2x e power 2x plus c3 e power minus 4x. To find particular integral yp is equal to 1 by d cube minus 12d plus 16 times e power 2x plus 2 e power minus x plus e power minus 4x. That is equal to 1 by d minus 2 whole square into d plus 4 times e power 2x plus 2 e power minus x plus e power minus 4x. Now splitting these three terms we get yp is equal to 1 by d minus 2 whole square into d plus 4 e power 2x, that is the first term. Second term 1 by d minus 2 whole square into d plus 4 2 e power minus x, plus third term is 1 by d minus 2 whole square d plus 4 into e power minus 4x. Now here we see a equal to 2, so substituting here for d equal to 2 we get 2 minus 2, that is 0. So 2 minus 2 whole square is 0. So we write the particular integral as x square by 2 into, here d can be written as 2. So 2 plus 4, x square by 2, 2 plus 4 into e power 2x. And in the second term we see here a is minus 1. So substituting here d equal to minus 1, we get 1 by minus 1 minus 2 whole square into minus 1 plus 4 to e power minus x. Now in the last term here a is minus 4, substituting d equal to minus 4, here we get 0 in this term. So we write particular integral as x e power minus 4x and substitute here d equal to minus 4. So we get x e power minus 4x by 6 or minus 6 whole square, that is 36. So the particular integral is like this: x square e power 2x by 2 into 2 plus 4, that is the first term. Second term 1 by minus 1 minus 2 whole square into minus 1 plus 4 2 e power minus x, plus third term is x e power minus 4x by minus 4 minus 2 whole square. So after simplifying we get x square e power 2x by 12 plus 2 e power minus x by 27 plus x e power 4x by 36. Therefore, general solution is given by y equal to yc plus yp, that is equal to c1 plus c2x e power 2x plus c3 e power minus 4x plus x square e power 2x by 12 plus 2 e power minus x divided by 27 plus x e power minus 4x divided by 36. Thank you for watching this video. Thank you all.